Welcome to Unit 1, Lesson 14, Outliers. Our learning goal for today is to investigate outliers and how to deal with them. We have 2 learning targets today, so as we go through the practice problems, please keep these in mind. By the end of the lesson, you should feel comfortable making these 2 statements. Number 1, I can find values that are outliers, investigate their source, and figure out what to do with them. Number 2, I can tell how an outlier will impact mean, median, IQR, or standard deviation. By the end of this lesson, if you are comfortable making these 2 statements, then you are prepared moving into the next lesson. If at the end of this lesson you are not comfortable with making one or both of these statements, then please use class time to ask for further clarification so you can be prepared as we move forward. For vocabulary, we have outlier, a data value that is unusual in that it differs quite a bit from the other values in the data set. In the box plot shown, the minimum 0 and the maximum 44 are both outliers. You can see in the diagram we have that dashed line that says 1.5 times IQR. This is how we're going to find outliers. We will take the IQR, which is the distance between Q1, which is the left side of the box, and Q3, which is the right side of the box. We take that distance and we multiply it by 1.5. Then we add that to the right side of the box and we subtract it from the left side of the box, and anything outside of where that dashed line is, we would consider an outlier. You can see that the end of the whisker at 0, showing our minimum, is outside of that dashed line, so it is an outlier. On the other end, you can see that the right side of the whisker at 44 is also past that dashed line, indicating that it too is an outlier in this situation. Next, we have standard deviation. This is a measure of the variability or spread of a distribution calculated by a method similar to the method for calculating the MAD, or mean absolute deviation. The exact method is studied in more advanced courses. Next, we have statistic. This is a quantity that is calculated from sample data such as mean, median, or MAD, mean absolute deviation. For our first practice problem, it says the number of letters received in the mail over the past week is recorded. So each of these numbers is a number of letters received on one day. Which value appears to be an outlier? So just by appearance, 2, 3, 5, 5, 5 all seem to be closely grouped together. And then we have 15, which seems to be really far away. So it appears 15 would be our outlier. So choice D would be the answer to this one. They're not actually asking you to calculate the outlier. They're just asking you based on appearance. So they just want to make sure you understand that an outlier is a number that seems to be fairly different from the rest of the numbers. Our next practice problem. Elena collects 112 specimens of beetle and records their lengths for an ecology research project. When she returns to the laboratory, Elena finds that she incorrectly recorded one of the lengths of the beetles as 122 centimeters, which is about 4 feet. What should she do with the outlier 122 centimeters when she analyzes her data? So the key here is that she incorrectly recorded one of the lengths. She knows it was a wrong measurement, and because there is evidence that that number is wrong, then we get rid of it. So Elena should remove the outlier because she knows it was a mistake. The only time that we remove outliers is if there is evidence of it being wrong. We do not remove outliers simply because they are outliers. If that had been correctly recorded, then we would leave it in and it would just be an outlier. But because she knows that she incorrectly recorded it, then she can go ahead and remove it. In our next practice problem, Mai took a survey of students in her class to find out how many hours they spend reading each week. Here are some summary statistics for the data that Mai gathered. We have a mean of 8.5 hours, a standard deviation of 5.3 hours, a median of 7 hours. Our quartile 1, is 5 hours, and our quartile 3 is 11 hours. Number 1, give an example of a number of hours larger than the median, which would be an outlier. Explain your reasoning. So, if we are looking for outliers, then we only care about quarter 1 and quarter 3, and then we'll need to refer to the median. Mean and standard deviation are not used in calculating an outlier. So the first thing I need to do is find the interquartile range, the IQR. This equals Q3 minus Q1. So in this case, Q3 is 11 hours and Q1 is 5 hours. And 11 minus 5 is 6. Now we need to find our 1/2 times IQR. So IQR times 1.5 equals 6 times 1.5, which is 9. So this is what we are going to add and subtract from the box. So number 1 wants to know the number of hours larger than the median, which would be an outlier. So for number 1, we are going to take Q3 and add the IQR times 1.5. Q3 is 11, and we just said our IQR times 1.5 is 9. So that equals 20. Any hours greater than 20 would be an outlier. So 25, 30, anything over 20 hours would be an outlier. Number 2, are there any outliers below the median? So if we're looking below the median, then that means we're going to subtract the IQR times 1.5 from the Q1. So if we do that, that would be 5 minus 9, which is -4. It would be impossible for students to read negative hours. So the answer would be there are no outliers below the median and again, this is because in the context of this problem, our answers are number of hours that students read. So if it has to be outside -4, that would mean students are reading negative hours, and that's not possible. If you have any questions about how to identify where your outliers begin and how to interpret them in context, please use class time to ask for further clarification now so that you are better prepared as we move forward. The box plot shows the statistics for the weight in pounds of some dogs. Are there any outliers? Explain how you know. So to identify our outliers, we first need to calculate the IQR. This is Q3 minus Q1. We can see that Q3 is right here at 55. And we can see that Q1 is on the left at 35. 55 minus 35 is 20. Now we need to identify the IQR times 1.5. That would be 20 times 1.5, which is 30. So now we would subtract this IQR times 1.5 from Q1. Since we said Q1 is at 35, we said that IQR times 1.5 is 30. That means anything below 5 would be our outlier. And since the left-hand whisker of our box plot stops at 10, that means the minimum value is 10. There are no outliers to the left. Now we need to check on the right side. We said that Q3 was 55. We said that IQR times 1.5 was 30. So our other fence is going to be at 85. Right here. We know there is at least one point at 95 because it is the maximum. There may or may not be points between 85 and 95. So anything that is out here would be outliers. So the answer is yes. There is at least one outlier at the maximum of 95. If you have any questions about how to calculate your outlier fences or how to identify whether there are outliers on a box plot, please use class time to ask for further clarification so that you are prepared as we move forward to the next lesson.